Good morning, Amherst. Let's talk a little bit today about reference table supplemental 2, how that compares to what it had replaced, which was table I on our current version of the table. I like table I better. Give credit where credit's due. Table I is written in such a way that these delta H values apply stoichiometrically. The supplemental table harkens back to a different way of looking at things. If you look at the units here, first thing you'll notice about table I is you're at 1 atmosphere and 298 K. Well, that's T in our equation. Delta G equals delta H minus T delta S. T is right here, 298 K, 25 degrees Celsius, a warm room. If you look at the units here, heat of formation, kcals per mole. So they're talking about forming 1 mole of these substances from their elements. That's an important consideration. We'll talk about that in a second. But they also give you the free energy change of formation in kcals per mole. So they give you delta H, they give you delta G, they give you T. Algebraically, your job is to solve for delta S. But one of the things that is a little misleading is that this is written per mole. So we're going to do number 1 together. So it says we're forming 1 mole of ammonia. Well, look at the elements that are in ammonia. You've got nitrogen and hydrogen. They are both Hofbrinkel, so nitrogen comes in pairs when it's by itself, and hydrogen comes in pairs when it goes by itself. Now if I go to balance this equation, I need 2 nitrogens over here. Well, that gives me 6 hydrogens, so I need 3 here. Okay, so I've balanced the equation, but now I've formed 2 moles. Well, one of the things that we'll use from time to time will be fractional coefficients. It's a way of thinking things through to balance it out for 1 mole. If I want 1 mole of product, I have to divide everything by 2. 2 over 2, that'll give me 1 mole. So the equation boils down to 1/2 of N2 plus 3/2 of H2 would give me 1 mole of NH3. It's not often that we do employ fractional coefficients, but this is one spot where we will. Alright, so I'm going to look at the table, and it says for ammonia, the enthalpy change of formation, the little f is formation, that's what it is. It's element plus element goes to compound. You don't start with a compound, you start with an element and another element, whatever elements are in the compound. And it says delta H for ammonia is negative 11.0 kcals per mole. And the delta G of formation for ammonia is negative 3.9 kcals per mole. And they also kind of hid in their temperature is 298 Kelvin. So now it's just algebra. Girls have true sensitivity, guys have no true sensitivity. They give you delta G, it's negative 3.9 kcals per mole. They give you delta H, it's negative 11.0 kcals per mole. Minus 298 Kelvin times delta S. First thing I'm going to do is I'm going to add 11 kcals per mole. To each side of the equation. So, negative 3.9 plus 11. Where's my solutions thing? I don't want to plug it into a calculator, but if I have to, I will. That is 7.1 positive kcals per mole. Now, if I divide each side by negative 298 Kelvin, that's a Kelvin there, I'll be left with delta S. So watch my sig figs here. If I've got 7.1 divided by 298, and that's a negative number, I end up with 2 sig figs of a negative 0.024. Now what about my units? How does this work out? Dimensionally, if I have kcals per mole divided by kelvins, that's the same thing as kcals per mole times 1 over Kelvin. So my units turn out to be kcals over moles times Kelvin. So 0.024 kcals per mole dot K. Your worksheet's going to ask about these comments, so you're going to list out the values. Write your equation, list out the values, and what about the comments? Well, let's go back and review. We had a negative delta H. That's favorable. We had a negative delta G. That means this is a spontaneous reaction. We had a negative delta S. That's unfavorable. But we did have a spontaneous reaction, so whenever it's spontaneous, whatever is favorable is considered a driving force. The driving force in this equation at 298 Kelvin is delta H. Tungsten? What is it? He's all fired up. He was chasing birds earlier. Okay, so you've got 5 more of those to do. I'm also going to make a worksheet, a quiz if you will, for thermodynamics, free energy, and entropy multiple choice. So I'll set up another form in Google Classroom. There are 20 questions. There's one in here about equilibrium. I think it's number 11. It's a little misplaced, but it says delta G at equilibrium. At equilibrium, delta G is 0. It's just something you need to know, need to remember. So at equilibrium, delta G is 0. If you watch the video, you'll know that the answer to number 11 is A. All right, you've got 5 more problems to do on worksheet 4, and then 20 multiple choice, and I'll collect the multiple choice as a grade. Come here. Come here. You can say hi. Let's see if we can flip the camera. No? No. This is what I deal with on a daily basis. All right, see you later.